All right, sorry I'm not going to be there with you guys today. And sorry I forgot to remind you that I wasn't going to be there today because I did know ahead of time about this. But you have this wonderful video. All right, anyway, let's go ahead and get started. So today we're going to look at solving two-step equations with variables on one and two sides. We looked at this a little bit. We're going to look at it in more detail now. So before we do that, though, let's remind ourselves that inverse operations are operations that undo each other. And that's important. I want you to think about that while you're solving equations. So the inverse operation of addition is, you're right, subtraction, because I knew you were thinking that. And the inverse operation of division is multiplication. All right, so we're going to focus on using inverse operations to get the variable by itself. Now, another thing that a lot of people don't think about when they're solving equations are these two ideas here. So let's look at the one in green first. So when a number is being added or subtracted to the term with a variable, we use inverse operations to turn that number into zero. And why do you think we do that? Well, because when you add or subtract zero, that something stays the same, and that's the key. So if we look at these two problems here, then we want to focus on getting the 4x by itself, but the first thing we'll have to do is get rid of the -7. It's like a -7. Remember, the minus sign makes it negative. And so we want to turn this into 0. So we're going to turn it into 0 by adding 7 onto both sides. That way, -7 plus 7 is 0 and cancels out. That's why they cancel out. And then we get 4x equals 12, and we would solve from there. We're not going to worry about that right now. Now, where this becomes tricky is something like this one. But if you focus on, there's an addition here between the number we want to get rid of and the variable. So we want to make this equal 0. So right now it's a -3. What do you do to a -3? You add 3 to make it equal 0. So even though this is addition, we're using addition again to isolate the variable. And that's because we want to turn this into 0. This way we're undoing the -3 with +3. So those would cancel out, and we have 9x equals 5. And then again, we would keep solving to get the x by itself. If we look at this one with multiplication or division, then it's the same kind of idea, but this time when you multiply or divide, you want to think about turning something into 1, because when you multiply or divide by something or something by 1, it stays the same. So in this case, here's the x. We want to get rid of the -3. We're going to divide by -3 because we want this to equal 1. -3 divided by -3 is 1. That's why they cancel out. And then we would get x equals, and a positive divided by a negative is negative. And then we're just going to leave it as a fraction. I'm going to go ahead and move these down just a little bit. Okay, same thing over here. We want the x by itself. It's being multiplied by 5, so we're going to use division, but we want to think about turning the 5 into a +1, so we're going to divide by 5. And then those cancel out, and 10 divided by 5 is 2. And then the next thing over here, this time we have division, and we're dividing by 4. So we're going to multiply both sides by 4 because 4 divided by 4 is 1. So those cancel out, and we have x equals 32. Now I have a little star over by this one for a reason, and that's because the x is in the denominator. We're not really going to focus on these right now, but I did want to show this to you. It's division, and we want to get rid of the 3. However, whenever you've got division, you always have to multiply both sides by the denominator. So we're going to have to multiply both sides by x. And that's because this is 3 divided by x. X is the thing that's divided, that's doing the dividing. So it's that we're going to undo with multiplication. So just always multiply by the denominator. And then we'd have, whoops, 3 equals 10x. Now we can divide both sides by 10 to turn this into 1, and we get 3/10 is x. So that's kind of a special case. And like I said, we're not going to really focus on that right now, but I did want to show it to you right now. Okay, now that we got those, let's try these. So you guys go ahead and pause the video right now, try these on your own. And then when you think you got them, check with your neighbor first. And then when you think you got them, go ahead and unpause the video and we'll take a look at these together. All right, I really hope you pause that video and try these on your own. You're going to get so much more out of the lesson if you try things on your own first, even if you don't get it right. Believe me, there's something about the way the brain works that you're going to get more out of it. But here are the solutions. We want to get the x by itself first, by itself. And so we're going to undo the addition or subtraction first. We want to turn that +7 into a 0 by subtracting 7. That turns into 0. We have 3x on the left, and 10 minus 7 is 3. Now we have multiplication. We're going to undo with division, and 3 divided by 3 is 1, which is what we were looking for. And then over here, 3 divided by 3 is also 1, and there's our answer. Right over here, we want to get rid of the 3, but it's a positive 3 that's with subtraction, so we're going to have to turn it into 0 by subtracting 3. 3 minus 3 is 0. That gives us the negative 2x. Negative 15 minus 3 is negative 18. Now we want to turn that negative 2 into a positive 1. Negative 2 divided by negative 2 is 1. Negative 18 divided by negative 2 is 9. And there is our answer. And then over here, we want to get rid of the positive 9. So we're going to subtract 9 from both sides to turn that into 0. That way that cancels out. We still have x over 4, and 8 minus 9 is negative 1. Now we want to turn that dividing 4 into a 1 by multiplying by 4 on both sides. 4 divided by 4 is 1, so x is negative 4. Okay, last thing, now we want to look at variables on both sides of the equation. So in order to do this, just think about simplifying each side fully. A lot of times there's something to do on both sides. In fact, even with variables on one side, we should fully simplify. But then we're going to use inverse operations to cancel the variable from one side. And then we solve it just like we were doing the ones above. So we'll do this one together. And so on this side of the equation, we do have a 4 and a negative 7 that are like terms. They don't have a variable, so they're like terms. So we're first going to combine those, and 4 minus 7 is negative 3, but then we still have a 3x, and it's positive. And then we still have our 10x plus 8. And that's it. That's all we can do to simplify. So now we're going to cancel out the variable from one side of the equation. And you can pick. You can cancel out the 3x or the 10x. Totally up to you. I'm just going to go ahead. I like to always have my variable on the left. So I'm going to subtract 10x from both sides. That way, this is going to turn into 0, and 0 plus 8 will just be 8. So that'll cancel that out. So I have my negative 3, and then 3x minus 10x is negative 7x. Those have canceled out and are 0, and then we have 8. And now it's like the problems above. We're going to add 3 onto both sides to turn that negative 3 into 0. We're left with minus 7x equals 11. And then we're going to divide by negative 7 to turn that into a positive 1. And a positive divided by a negative is negative, and 11 divided by 7 isn't a whole number, so we're just going to leave it with 11 divided by 7. See, who needs a calculator? All right. Now I want you to try. There's 3 problems left. I want you to try those on your own. So pause the video again, check with your neighbor. When you think you're ready, come back and you can see the solutions. Okay. With this first one, we do have something being multiplied by parentheses, and there's a plus or minus inside. Remember, it's always got to be multiplication on the outside and plus or minus on the inside, and then you can distribute. So this is going to stay the same, 4 minus 7x, but then we have 3 times x, which is 3x, and 3 times 8, which is positive 24, and then we have minus 7. Now on the left-hand side, there's nothing to combine, nothing to simplify, so that stays the same. On the right-hand side, we can combine those. So the 3x will come down, and 24 minus 7 is positive 17. Now we can cancel out. I do want to show you, I told you I like to always get the variables on the left side, so I can't always cancel out this one, but you can cancel this one out too. It works. I'll get rid of the minus 7x by adding it to turn it into 0. Do that to both sides of the equation. So that cancels. We're just left with 4 on the left, and then 3x plus 7x is 10x. Now I can subtract 17 to turn that into 0. 4 minus 17 is negative 13. And I'm just going to move this down to give myself a little room. And then finally, I'm going to divide both sides by 10 to turn that into 1. And a negative divided by a positive is negative. 13 divided by 10 isn't a whole number, so I'll leave it like that. And there is our answer. So there's the first one. Let me try the second one here. I'm going to just move this down. Move this down a lot. Okay, this one. Again, we have distributing to do. There was multiplication on the outside and plus or minus on the inside. So left-hand side won't change. Right-hand side, I've got negative 3 times 4.2. I'm going to go off to the side. 4.2 times negative 3. Oops, looks like minus 3 times negative 3. So to do this, just multiply like normal. 3 times, ignore the decimal. 3 times 2 is 6, nothing to carry. 3 times 4 is 12. Then we have 1 digit after the decimal in the problem. So we're going to have 1 digit after the decimal in our answer, and a positive times a negative is negative. So that is negative 12.6. But we still have the x. And then negative 3 times negative 5 is positive 15. All right. Now we're going to cancel out that 12.6x by adding it to both sides. A 9 will come down. 2x plus 12.6x is 14.6x. Think of it as $2 plus $12.60. You have $14.60. These are now 0, so we don't need them. And we have the 15 left. Then we're going to subtract 9 from both sides. And 14.6x is left because that's 0. 15 minus 9 is 6. And then finally, we'll divide both sides by 14.6. That's going to be 1. And I'm going to be honest with you, I don't have a calculator handy. And this is one I would use a calculator with. I'm just going to leave it as 16 over 14.6. But we should divide And you can use a calculator to write your final answer. And I apologize, I wasn't prepared with a calculator when I made this video. But that's definitely one I would not expect you to do by hand. All right, let's look at the last one. I'm not going to box that answer because it's not really the final answer. We should divide. Okay, last one here. Oops. I put some fractions here because I wanted to show you. We're going to still, there's nothing to distribute. I mean, we do have parentheses, but there's nothing being multiplied on the inside, and there's no plus or minus, or on the outside, nothing being multiplied on the outside, and there's no adding or subtracting on the inside. So it's not really distributing. We're going to cancel out one of the x's though. So we're going to add 5/3 x onto both sides of the equal sign to turn that into 0. 2/3 plus 5/3 is 7/3. So we have 7/3 x minus 5. And we have a -1 on the left, or on the right-hand side. Now I'm going to add, whoa, I'm going to add 5 onto both sides to make that equal 0. We get 7/3 x equals, and that's going to be +4. Now here's a special case. When you are multiplying by a fraction, we're actually not going to use division. I mean, we kind of are, but if you remember to divide by a fraction, you multiply by the reciprocal. You don't remember, now you do. But remember, we want to focus on making that equal 1. So I'm going to multiply by 3/7 on both sides. Because that way 3's cancel. 3 divided by 3 is 1. And the 7's cancel. 7 divided by 7 is 1. And that does give us the x by itself. And then on the right-hand side, I can put the 4/1 and just go straight across. 4 times 3 is 12. 1 times 7 is 7. And there is our answer. Okay, so that's the notes. And make sure you've glued these into your notebook. And then the substitute will give you a copy of the homework, and you guys can start working on that. I'll see you on Wednesday. Bye.